Hi guys, so today we are going to do the advanced level 3 for geometry. I'm assuming that you've already been through level 1 and level 2, and once we have done level 3, we can be sure that we've aced the geometry topic. So let's dive into the questions. Let's start with question number 1. Find the length of the median to the hypotenuse of a right angle triangle with legs 6 and 8. With some median at point M such that Acha, this is 6 and 8, so you directly know this is 2 threes are, 2 fours are, so 2 fives are. So this is 10, and this is 5, and this is 5, right? So this is direct application of Apollonius theorem. If you remember, let's take this B, this is A, this is C. It says that A square plus C square is equals to 2M square plus B square by 2. If you've forgotten, you know how to derive it. Assume any angle, and if you know the cosine law, which you will go through in the trigonometry section, but still, so cos theta can be written as c square plus this side square plus this side square minus this side square upon 2c and 5, and cos theta in the bigger triangle can be c square plus this side and this whole side minus 8 square upon 2 into c into 10. And if you equate these two, you basically get c square plus 25 minus m square upon 10c, c square plus 100 minus 64 upon 20c, or 2c square plus 50 minus 50 minus 2m square is equals to minus 64. We'll take it here. So c square plus 14 is equals to 2m square, or c we already know 6. So 36, which is 50 by 2, or 25. So m is 5. Right? If you knew the formula, you could have directly put the values of A, C, and B, and you could have gotten M. But if you don't remember, you should know how to use cosine law. Question number 2. There are two tangents which are drawn from an external point P to a circle with center O touching at A and B. APB is given as 60 degree. AOB we need to find out. We know this is 90 degree. And this is what? Let me draw this. And because these two sides are equal, I know this will be 30 degree. So this will be 60 degree. And similarly, this will be 60 degree. So 120 degree. Right? Pretty easy if you look at it. You know P and PB are equal. Question number 3. In triangle ABC, angle A is 90. AD is the altitude to BC. BD is given as 4 and DC is given as 9. Okay. Let me just draw it in this way. So BD is 4, DC is 9, angle A is 90, AD is altitude. Find AD. So we have to find this. Right. Can I assume this to be C and this to be B? Can I say 16 plus C square? Sorry, C square is 16 plus, okay, we have taken X, so let it be X. And in this case, B square is 81 plus X square. And in the entire triangle, 9, 10, 11, 13 square is B square plus C square. Put it like that, 169, 16, 7, 97 plus 2x square. I need X, right? So x is 36. X is 6. Pretty easy. Yeah. Let's go to question number 4. Find the length of the direct common tangent between two circles of radii 8 and 3, whose centers are 13. So 8, 9, 10, 11. So basically, their radii is 8 and 3, and their distance total is 13, 8, 9, 10, 11. So this must be 2. And length of the direct common tangent between the two circles. So let that be the tangent. So I need this. I know that it will make 90 degree to both these circles, right? If you look at it, the perpendicular will be like this. Drawing the diagram becomes important geometry because sometimes you can visualize things only by making correct figures. So you know that this will be your right angle triangle, right? This is 8 minus 3, 5. Doesn't look like it, but you get the idea. This is 5, 8 minus 3. So this is 5. This is the tangent that I need to find out. And if I know this, so this is also 11. Sorry, 13. So this has to be 12 because this is also a right angle triangle. Fourth C. Yeah. So just about drawing whatever it is saying, and then you will automatically get redirected. Let's go to question number 5. A cyclic quadrilateral is given. So this is your cyclic quadrilateral ABCD. Angle A is given and angle C is given. So what is the value of x? So in a cyclic quadrilateral, sum of opposite angles is what, 180 degree? So can I directly say 3x plus 5 and 2x plus 15 is 180 degree? So 5x plus 20 is 180, or 5x is 160, or x is 32 degree. Very direct question, but just to make you understand that opposite angles of a cyclic quadrilateral are supplementary. Question number 6. Find the length of the median of triangle ABC where AB, AC and BC are given. Find the length of the median. AB is 7, AC is 9, BC is 8. So this is 4 and 4. Again, it's a direct application of Apollonius theorem. If you are aware, you know that wherever the median is coming from, sum of square of those two sides is equals to twice of the median plus the third side upon 2. This you should know. But if you don't remember, again, use the cosine law. Cos theta in this case will be c square plus a square by 4 minus the third side. I'm taking the smaller triangle, this. That's why I've taken a by 2 here. I'm just trying to derive it once upon 2c into this side. And similarly, if you put cosine law in the bigger circle, c square plus a square minus b square upon 2ac will be this. So if you equate these two, c square plus a square minus b square, and this is 2ac, this is also 2ac. Let that half come on this side, is equal to c square plus a square upon 4 minus m square. So if you just equate the two, c square by 2, if I take it here, a square by 2 in minus, so minus a square by 4 minus m square as it is, and plus b square by 2. So basically it becomes b square plus c square minus m square minus a square by 4 is equals to 0, or b square plus c square is equals to 2m square plus a square by 2. So in case you forget, you should be able to quickly derive it, but I would suggest that you remember this theorem, and after, if you remember it or you derive it, the question becomes nothing now. We need to find out m and we have to just substitute the values. Also remember that wherever this median is coming from, the formula applies like that. So b square plus c square I've taken. Now just put it is equals to 2m square plus a is given, right? 8. So this is what? 80 and 50. 130 is equals to 2m square plus 32, or this will come there. So this will be 12, 98 upon 2, or 49. So m is 7. Pretty standard question. Let's go on question number 7. A regular polygon has an internal angle that is 5 times its exterior angle. Interior angle n minus 2 into 180 degrees is the total sum of all the interior angles. Because it is regular, I can say every internal angle will be this. Sum of all the external angle of any polygon is 360 degree and n sides. So every exterior angle will be like this. If you know this, the question becomes nothing. Interior angle is 5 times the exterior angle. 10. So n is 12. 7th C. Right? Let's go to question number 8. Consider an obtuse triangle with all 3 sides as integer. Product of the 2 sides as 4. So find the third side. Okay. So we know that there is some obtuse triangle, and this is how obtuse triangle looks like. This is more than 90 degree, any one angle, because 2 angles cannot be more than 90. Product of 2 sides is 4. Find the third side. Okay. Product of 2 sides is 4. I say it can be 2 into 2 because these are integer, or it can be 4 into 1. Let's say case 1 where it is 2 and 2, and the third side, I don't know, let it be x. Sum of 2 sides is always greater than the third side. So 2 plus x should be greater than 2. X should be greater than 0. X should be less than 4. So x can be 1, 2, or 3. So basically it can be an equilateral triangle. It can be this. It can be this. These are the 3 possibilities. Let's take case 2. It is 4, 1 and x, right? So, or y. So it will be 4 plus 1 should be greater than y plus 4 should be greater than 1, and y plus 1 should be greater than 4. Sum of 2 sides is greater than third side. So we get from this that y should be less than 5. From here we get y should be greater than minus 3, and from here we get y should be greater than 3. So 3 and 5 I can only be 4. So the only case is 4, 1, 4. So 1, 2, 3, 4 cases I'm getting. So third side should be what? Product of 2 sides is 4. So this is the product. Third side is 4 here. Product is 4. Third side is 3 here. Product is 4. Third side is 1 here. Product is 4. Third side is 2 here. So basically, I think it is asking that how many values can the third side take? And according to this, I can see that if product of 2 sides is 4, then third side can be 4. But it is also saying it's an obtuse triangle. Wait, in this case, it's an equilateral triangle. Obtuse. What is obtuse basically? A square plus b square is c square, then it is a right triangle. A square plus b square is more than c square, then it is an acute triangle. And if it is less than c square, then it is an obtuse triangle. Now it is saying obtuse. So a square plus b square should be less than c square. Let's try this. 16 plus 1, 17 is not less than 16. So this is not the case. 4 plus 4 is less than 9. Yeah, this is the case actually. Or 9. In this case, 4 plus 4 is less than 1. No. 4 plus 1 is less than 4. No. This case also 4 is not less than 4. 8 is not less than 4. Only in this case, I can say that 2 square plus 2 square, which is 4 plus 4, 8, is actually less than third side 3 square 9. So I think third side should has to be 3. Answer for 8 should be C. Yeah. It's a very good question because of if I missed that obtuse triangle, so I thought number of values, but it's actually saying third side can only be 3. Very good question. Question number 9. How many isosceles triangles with integer sides are possible? So that sum of two sides is 10. Since it is saying isosceles, can I say two sides will be equal? So A, C and B, and it is saying that A plus B is 10. So one case will be that where B and C are the two equal sides. Another case can be when A and B are the two equal sides. A and B are the two equal sides. In that case, they both will be 5. How many isosceles triangle with integer sides are possible? Isosceles triangle. So this is I've used it. Now, in this case, let's solve this. This is easier. A plus B should be greater than C. That is what I know. So 10 C has to be less than 10. And B plus C has to be greater than 5. C has to be 0. So I think C can be from 1 to 9 any value. So it will be 5, 5, 1, 5, 5, 2, and so on up to 5, 5, 9. This is from case 1. 9 answer, 9 possibilities. In this case, since B and C are equal, can I write this also as B? So 2B should be greater than A and A plus B should be greater than B. So A should be greater than 0 and B should be greater than 2B should be greater than A. Also, A plus B is 10. So can I say A is 10 minus A, sorry, equal to A is 10 minus B. So 3B is greater than 10 or B is greater than 3 point, what is this? 9, 10, 3.33. So B can be 4, 5, 6 and so on. B is greater than 3. A plus B should be greater than B. A should be positive. That I know. And 2B should be greater than A. A plus B should be greater than B. B minus A. Difference of two sides is less than the third side. Again, I got the same thing. Difference of two sides should be greater than the less than the third side. So from here, I'm getting that B can be any value. A plus B is 10. Right. So A has a limit, right? So in this case, let's say B is 4. Then the other side is also 4 and A has to be 6. So this is 1. If B is 5, other side also has to be 5 and the other side has to be 10 minus 5. 6, 6, 10 minus 6. 7, 7, 10 minus 7. 8, 8, 10 minus 8. 9, 9, 10 minus 9. 10, 10, 0 cannot be. So these are the cases. Also 5, 5, 5 is getting repeated. And they're all possible, right? Because if it is 991, 10, sum of two sides should be greater than third side. Yeah, these are all the cases. So 1, 2, 3, 4, 5, 6. 6 cases from here, 9 cases from here, and 5, 5, 5 is getting repeated. So 9 plus 6 minus 1 or 8 plus 6. 14 should be the answer, 9th. Yeah. Let's go to question number 10. What will be the third side of a triangle for maximum area if the two sides are 12 and 13? Third side of a triangle for maximum area if there are. See, we cannot directly assume it to be a right angle triangle and say this. This is also one of the cases, but we cannot assume it. It could be 12, 13, and this also. In this case, we know area will be half into base into height or 30. But if I take these two sides, this will be root of 144 plus 169 or 10, 13, 1, 3 root 13. So half into base into height, which is more like, right? So it's 78. Yeah. What will be the third side if the two sides are this? So answer should be root 313 for the third side. If you increase this, again area will decrease, and if you do this, area will decrease. Area is maximum when it's a right angle triangle for sure. So answer should be 10th D, none of these. Yeah. Very good question, but we will assume that it's a Pythagoras theorem, but not always. I mean, it's not a Pythagoras triplet. Equilateral triangle has a square inscribed in it such that one side of the square lies along the side of a triangle. Find the ratio of the area of the square, let this be A, to that of the equilateral triangle, let this be S. So I need area of the square and area of the triangle. So A and S, I need to find a relation. I know this is 60, right? This is A. Let this be M. BM, let's find out through trigonometry. Cos 60, curly, black base, hair, hypotenuse. This I don't know, but this I know. Let's put sine 60. So P people have perpendicular upon hypotenuse. Perpendicular upon hypotenuse. Sine 60 is root 3 by 2, right? So BM will be 2A by root 3. I got BM. Similarly, let's find out AM. This is also 60. And if I put a perpendicular here, this will be A by 2. It's an equilateral triangle. So A by 2 and A. So this will be root 3 by 2A. How? Pythagoras theorem. No, wait. This will be A square minus A square by 2. Then this is A by 2. In this small circle, triangle, this is A by 2. And this we need to find out. So again, let's put sine 60. Some people have, but okay, cos 60 B upon H. So cos 60 sine 30, which is half. So AM is A. This is A. And this we find out as 2A by root 3. And this total is S. We got our relation, right? Can I say 2A by root 3 plus A is S, or 2 plus root 3 upon root 3 into A is S? Now put the value. A, we can put anything. Let's put A square as root 3s upon 2 plus root 3 whole square, and the root 3 by 4 s square. So this is basically 3 upon 2 plus root 3 whole square into s square, and this will become 4 by root 3. So this is 4 by 4 root 3 upon 4 plus 3 plus 4 root 3. So 4 root 3 upon 7 plus 4 root 3. Let's try to match options. If I do this, this is what? 16 into 3. This is 49, this is 48. So 1. So 4 root 3 into 7 minus 4 root 3. Probably none of these. 12 upon 12 plus 7 root 3. Okay. If instead of rationalizing, I multiplied by 4 root 3, 16 into 3 upon 28 root 3 plus 16 into 3 and 8, 14, 4, 7. 4 into 3, 7 into root 3 plus 4, 4 into 3. 12 upon 12 plus 7 root 3. Okay. So my bad. I should have not opted for none of these, but rather if you have to match, so instead of rationalizing the denominator, if we rationalize numerator, we get to this option. All right. You got the concept. So question number 12, a triangle with sides square root of the sides of another triangle. A triangle with sides square root of the sides of another triangle. A triangle with sides square root of another triangle has to be. Can't say. I know this, that a plus c has to be greater than b, and root a plus. Okay. In this case, if you are aware a square plus b square is equal to c square, then you know it's a right angle triangle. A square plus b square is greater than c square, then you know it is an acute. And if it is more than less than c square, then you know it is obtuse. So from in this case, um, let's say a square plus c square is a plus c, which is greater than third side ka whole square, which is greater than b or less than b. It is greater than b. From this I know. And because square of sides is greater than the third side, it is acute. So I think 12th is B. Yeah. Very good question because it looks very complex, but as soon as you got into square root, you know the property a square plus b square, and you know from the first that a plus c is greater than b. Similarly, if I square these sides, I get the third, it is greater than the square of the third side, which is a property of an acute angle. So, good question. Let's go to question number 13. Consider right angle triangle with in radius 3 and circumradius as 8. So circumradius means that this is also in the, this is 8 and this is also 8. I think if you are aware, any triangle, if I take ABC, this is A, this is C. So this is direct application of this formula that, in case of a triangle which has a in circle of, let's say, radius r, we know that a plus c minus b upon 2 is r. But in case you don't remember it, you can quickly derive it also. Let's assume this to be two tangents to a circle. So this x and x, let's assume this as y and y, and this is z and z. So because this is r, right? So can I say x plus r is c, right? This is already we know is r. X plus r is c. Similarly, can I say this I've assumed as z plus r is a. Add the two, x plus z plus 2r is a plus c. And since this is x and this is z, this is b. So, you know, you get to the same formula. But it's good to remember because then the question becomes very easy. You know that a, in this case, we don't know a, we don't know c, we know b is 16 because this is basically the circumcenter. So I know that this is the diameter and this is equals to 2r, which is 6. So a plus c I got as 6 plus 16, 22 from the first, right? Now also because it's a right angle triangle, a square plus b square is equals to 16 ka whole square, correct? Now what? What do I need? I need the area of the triangle. So I need a and c. Got it. So a plus a square plus c square. Sorry. Can I write it as a plus c whole square minus 2ac is equals to 16 square? So 2ac becomes 22 square minus 16 square, or 6 into 38 upon 2. This is AC, right? So AC is 38 into 3. I need area, which is half AC. So area will be 38 into 3 upon 2, or 19 into 3. 20 into 3 is 60. So 57. 13th B. Yeah. But good question. If you don't know the formula, please be very comfortable in deriving because it's not that big of a deal. It doesn't take much time. What is the ratio of the longest diagonal to the shortest diagonal of a regular hexagon? Since it's a regular hexagon, this question is possible. You know, in a any regular polynomial, this, what do you call it? Polygon area, this every internal angle will be this. So because it's a hexagon, so 6 minus 2 upon 6, 4 by 6, 2 by 3, 6, 12, 18. So 120 degree. So can I say every angle is 120 degree? What is the ratio of the longest to the shortest diagonal? I know shortest diagonal for sure will be like this. And longest diagonal could be this, correct? For sure. Now, any all the sides is A. I need this. So I'll get the longest one also. This is A. This is 60 degree. So this is A sine 60 is, sorry, cos 60 is x upon A, or sine 30 or half. So x is A by 2. So this is A by 2, this is A by 2. So basically this total is 2A. So I got the longest diagonal as 2A. Shortest diagonal this. This is 120 degree, right? Really cos 120 degree, you know, A square plus A square minus, let this be some value C square upon 2A. If you don't remember this, then also you can do it. You can put a perpendicular here. So this becomes C by 2. And this is again 30 degree. right? Because this was 60, this is 90, so you're sure this is 30. You can do this is c by 2. So sine 30 degree will be, or cos 30 degree will be c by 2 upon a. So c can be written as 2a for root 3 by 2 or root 3a. So you got c as root 3a. So shortest is root 3a. So it is asking shortest by longest by shortest, which is 2 by root 3, 14th a. Very easy if you make the diagram and start dissecting. All right, let's look at question number 15. We have an octagon and quickly we'll find out the every internal angle. So 6 by 8 into 180 or 3 by 4 into 180, 45, 135 degree. Again, longest and shortest, this will be the shortest and probably this will be the longest. So I think X is pretty easy because this is A, this is also A. You use cosine law, which is A square plus A square minus X square upon 2A square. 35 is minus 1 by root 2. So this will become 2A square minus X square is equals to root 2A square with a negative sign, or A square into 2 plus root 2 is the X square. Right, so you got X as a 2 plus root 2 and whole root. So now we have got the shortest diagonal. Let's find out the longest diagonal. So if you look at this is A, this is 90 and every angle is 135. So this is 45. So this is 45. Can I say this is A by root 2? And this is A by root 2. This is also A by root 2. Similarly, this is also A by root 2 and this is A. So I got in this, I got these two sides. Can I find out this? This is basically root 2A plus A because A by root 2 plus A by root 2 is 2A by root 2 or root 2A. So this side I know, this is A. I need to find the third side. So use A square plus root 2 plus 1 into A whole square by root. This is your longest diagonal. So 2 plus 1 plus 2 root 2 plus 1 A and root 4 plus 2 root 2 A. This is your longest diagonal and this was your shortest diagonal, and longest by shortest will be let's see, if I take L square upon S square, it is 2 plus root 2 upon 4 plus 2 root 2. Let's try to simplify. 2 plus root 2 into 4 minus 2 root 2 upon 4 square minus 2 root 2 whole square. Let's see, 4 to the 8, 4 root 2 plus 4 root 2 minus 4 upon 16 minus 4 into 2, 8. So 8. Now this is getting cancelled. So this is basically 4 upon 8, half. So 1 L by S should be 1 by root 2, 15th A. It is asking longest to shortest, and I have done shortest by longest. So basically, this was the long one. I've taken it in denominator. Silly mistake, but it's fine. You get the idea. All right. Let's do last question. Question number 16. Find the altitude drawn to a triangle where AB is equal to AC, which are both 18, BC is 24, altitude drawn to the side AC. Okay. Since this is isosceles, I have to find this altitude, right? Let's take this as x, and this will be 18 minus x. These two angles are equal. I want to use Pythagoras and equate this h height. 18 square minus x square should be h square, and from, in this case, 24 square minus 18 minus x square should be h square. If I equate these two, I can find x, and if I put it in any one, I can get h. Let's do that then. Eighteen minus x whole square minus x square is equals to 24 square minus 18 square. So this is 6 and 42. And this is 18 minus x plus x and 18 minus x minus x. So can I say 6 3s are 3, 14, 18 minus 2x is 14, 2x is 4, x is 2. As soon as I get x, I can put it in any value and get h. So this is 18 minus 2 square. So 16 into 20, or 3 is h square. So 320. Two into 4 into 4 into 10. Or 4 will come out. This is 5 into 3. 2 will come out and root 5. Yeah. So we're done with geometry, and I think after going through the 3 levels, you also will feel very confident to be able to face any type of question that comes. Obviously, there is always some new question that you should keep on practicing, but geometry, you will have certain confidence after you've gone through the 3 levels. So I'll see you with the next topic. Thank you so much and happy learning.